welcome to our lecture video. In this lecture video, we are going to talk about Thomas algorithm. What is Thomas algorithm and in which conditions we'll be using Thomas algorithm. So as you can see here in the paper, we have certain system of equations. We have considered certain system of equations. We will not be using Thomas algorithm for each and every equation. We will be using Thomas algorithm for certain equations which will follow a certain pattern. So as you can see here in our first equation, we have our variables x1 and x2. We have two variables x1 and x2, while we have three constants b1, c1 and d1. And as we move on to our second equation, we have the same variable x1, same variable x2 gets continued, but we get an additional new variable x3. So as you can see here, in our first equation we have two variables x1 and x2 and three constants, but as we move on to our equation 2, we have three variables x1, x2, x3 and four constants a2, b2, c2 and d2. And as we move on to our third equation, what you can see here is we have our constants x2 gets over here, x3 gets over here, and we get our new constant and we get our new variable x4. So as you can see here, as we move on to our third equation, we have our variable x2 which is of equation 2, variable x3 which is of equation 2 as well, and we get our new variable x4. So as you can see here, we are following a certain pattern. We started with two variables x1 and x2, but now we have moved on with three variables while x1 getting disappeared. So we follow the same pattern. So we will be ending with two variables. We begin with two variables x1 and x2, but we will be ending with different variables which can be x4 or x5 or x5 or x6 according to our number of equations. So let's say here our n simply represents our number of equations. So right now we have here n number of equations, and we'll have our n and we'll end with our xn variable and xn minus 1 variable, which will be different from the variables we begin with. So it's quite difficult to understand over here. So let me give you an example. Let me give you a workout example which we'll be solving later on. So we have our equation 4x plus 8y equals to 8, 8x plus 18y plus 2z equals to 18, and 2y plus 5j plus 1.5w equals to 0.5, and 1.5j plus 1.75w equals to minus 1.75. So for certain equation, for equations like this, we'll be using Thomas algorithm to find the value of x, y, z and w. So we don't need to pay any attention to the constants. We don't need to look out for them. What we need to look out for is the pattern of variables. As you can see here, we begin with variable x and y, which is x1 and x2. Next we have same x and y, and then we get additional new variable z. And as we move to our third equation, we are continuing the variable y and j, and we have an new additional variable w, but the variable x gets missing. And to our final equation, our y variable gets disappeared, and we get our variable z and w. So as you can see here, we begin with two variables and we have ended with two variables, and we begin with variable x and y, while we have ended with completely different variables z and w. So for such an equations where we follow this pattern of variables, we'll be using Thomas algorithm. So that was all about when we'll be using Thomas algorithm. Now let me talk about how we'll be using Thomas algorithm. So in our Thomas algorithm, we'll be firstly calculating the value of alpha. Next we'll calculate the value of beta, and we'll be using that value in xn, and we'll be using that value to get our value of xn. So and we'll be solving our equations likewise. So as you can see here, firstly what we'll be doing is we'll be setting alpha 1 equals to beta 1. So what is beta 1 is? Beta 1 is our constant of x1. So whatever constant x1 carries, we'll set that to alpha 1, and then we'll calculate our alpha I, which will be equal to bi minus ai ci minus 1 divided by alpha I minus 1. Here our I variables, I will run from 2, 3 till n. So our n simply represents our number of equation. So for this we have 1, 2, 3, 4 number of equations. So our value of n will be 4, and our I will run from 2 to 4. So firstly we have alpha 1, next we'll be calculating alpha 2, alpha 3 up to alpha 4. So that was for alpha. Next we'll be calculating beta 1. So what does beta 1 is? Beta 1 is simply the ratio of d1 by b1. So we have our d1 from here and b1 from here. It is the ratio of simply the two constants. D1 is the constant at the right, while b1 is the constant of our x1, our constant of our first variable. So simply we'll calculate beta 1 this way. Next we'll be calculating beta I. So in this case as well, our beta I will run from 2 to 4. For this our work at example. As I explained before, here n simply refers to the number of equations. How many number of equations we have, n will refer to that. We may have 2, 3, 4, up to n number of equations, and we'll be calculating our beta I using the formula di minus ai beta I minus 1 divided by alpha I, and here our I will run in the same way from 2, 3 till n number of our equations. So our beta 1 will simply equal to d1 minus a1. We have already found out our beta 1. So now our beta 2 will be, our I runs from 2, so our beta 2 will be d2 minus a2 beta 1 divided by alpha 1. So this will be more clearer when we will be doing our workout example. So at last, when we have calculated our alpha 1 beta 1, now we'll be calculating our xn. So firstly what we'll be doing is, our xn will be the solution of our equations, and firstly we need to set xn equals to beta n. So our xn will be equal to beta n, and our xi will be equal to beta I minus ci x I plus 1 divided by alpha I. So our alpha and beta, we ran our I from 2 till n. So 2 till n, what we will be doing in opposite way. Our I will run from n minus 1, n minus 2 till 1. So we have our n as 4 for this equation. So n simply refers to our number of equations. So firstly we'll be setting x4 equals to beta 4. Firstly we will set, in n we'll put 4, x4 equals to beta 4. We'll be finding beta 4 from here, and after doing that we'll be calculating x3. 4 minus 1 is 3. So first we will calculate x3, x2, and we'll go till x1, and our x4, x3, x2, and x1 will be our solution to this equation. So I have basically explained what is a Thomas algorithm, what are its procedure and when it is used. So now we'll jump on to now we'll be solving our workout example to make our concept more clearer. So now we'll be solving this equation using our Thomas algorithm. So as I explained before, it follows a certain pattern. We have our variables x and y. Next we have x, y, j, y, j, w, and it ends with variable z and w. We begin with two variables, and now we are ending with two variables. So we have total of four variables x, y, z, w, and 4 number of equations, and we'll be solving it using Thomas algorithm. So as a suggestion, what I like to do is, to make our work easier, what you can do is, we can write the pattern of Thomas algorithm. We can have b1 x1 plus c1 x2 equals to d1. So I'm basically writing this system over here, this system, just to make our work little bit easier. So next we'll be writing here a2 x1 plus, we are beginning with variable b1 c1. Next will be a2 a3 a2 b2 b1 c1 a2 b2 and c2 a2 b2 x2 plus a2 b2 c2 x3 equals to d2. So we'll have simply d3 and d4 over here, d4 over d3 and d4 over there. So now we'll have variables x2 plus x3 plus x4, and we'll have our variables x3 and x4 at the end. Now for our constants, we had b1 c1 a2 b2 c2. We'll have a3 b3 c3, and at last we'll have a4 and b4. So you can simply write it in this way to make our work easier. So now firstly, before solving this, we'll be writing this in the form of augmented matrix. So let me just write it over here simply. The augmented matrix is so now we'll be writing this in the form of augmented matrix. So we have our x 4 8 0 0 is to 8. So let me just write it down quickly. So we have 8 18 0.5 minus 1.75. So at the right side we'll be writing all this d1 d2 d3 d4 values minus 1.75, and now we'll be writing x is 8, y is 18, z is w, while our w is 0. So in our here we have x 0, y is 2, z is 5, w is 1.5, and for our final we have x and y both 0, while our z is 1.5 and w is 1.75. So as you can see here, our main diagonal we have all non-zero elements. So that's why this is also called as the tridiagonal system, where we have our main elements, all the elements of a diagonal as non-zero. So now we'll be solving it using our Thomas algorithm. So firstly we'll write the value of I. So as I explained before, our value of I is equal to the number of equations, and now we have here we have 1 2 3 and 4. So our I is 4. So firstly as I explained before, our first and foremost step is going to be setting alpha 1 equals to b1 and computing the value of alpha I from alpha 2 alpha 3 till up to alpha 4. So we'll be doing that. So now our firstly what we'll be doing is we'll be setting alpha 1 equals to b1. So we have our alpha 1 equals to b1. What is our b1? b1 is 4. So as I said in the before, we are going to write this just to so that our work will be easier. So for this reason only I said to write this format. So now next we'll be writing and compute. Now we'll be computing the values of alpha 2, alpha 3 and alpha 4. Alpha 2, alpha 3 and alpha 4. So as explained before, our formula for alpha is going to be bi minus ai c I minus 1 divided by alpha I minus 1. So if we put the value of 2 over here, we get alpha 2 equals to b2 minus a2 c1 divided by alpha 2. So alpha 1, sorry, alpha 2 equals to b2 minus a2 c1 divided by alpha 1. So let me simply write over here, alpha 2 equals to b2 minus a2 c1 divided by alpha 1. So let me simply write over my formula. Our formula for alpha I equals to, our formula for alpha I is bi minus ai ci minus 1 divided by alpha I. So that's my formula. So I'm simply going to write that. So I get alpha 2 equals to b2 minus a2 c1 divided by alpha 2. Similarly alpha 3 will be equal to b3 minus a3 c2 divided by alpha 2, and alpha 4 will be equal to b4 minus a4 c3 divided by alpha 3. So let me write down all the value of b2, b3, b4 and all these values from over here. So as you can see here, b2 is over here, x2 which is 18. So let me simply write 18 minus a2 is 8 into c1. What is c1 is c1 is over here, c1 is 8 divided by alpha 1. Alpha 1 we have calculated the value of alpha 1 over here. So if we solve this, I'll get 2. And next we have b3. So b3, where is b3? b3 is over here, third equation, second variable constant, which is 5 minus a3. So a3 is 2 into c2. What is c2? C2 is over here, c2 is second variable, third constant, which is 2 divided by alpha 2 is, alpha 2 as just calculated, which is 2. So if I solve this, I get 2 gets cancelled out, 5 minus 2 is 3. So now for alpha 4, what I need is b4. What is b4? b4 is over here, 1.75 minus a4. What is a4? a4 is over here, 1.5 into c3. So what is c3? c3 is over here, which is 1.5 into 1.5 divided by alpha 3. So if I solve this, I'll get my value as 1. So now I have successfully computed my value for alpha 1, which is 4, alpha 2, alpha 3 and alpha 4. So now for our next step, as I explained before, what we'll be doing is we'll be finding the value of beta. So in order to find the value of beta, so what I'll be doing is I'll be finding the value of beta over here. So firstly, so as I explained before, for our next step, we need to find the value of beta, and we need to set beta 1 equals to d1 divided by b1. So let me just do that. Let me setting beta 1 equals to d1 divided by b1, and we get this as beta 1 equals to my d1 is 8, b1 is 4, so 8 divided by 4 equals to 2. So as I explained before, my formula for beta I equals to di minus ai beta I minus 1 overall divided by alpha I. So we'll be using that formula. Next we use compute beta 2. Beta 2 will be equal to d2 minus a2 beta 1 divided by alpha 2. So we have our value of d2 18 minus a2 is 8 into beta 1 is 2 divided by alpha 2 is 2. So we get on solving this, we get our value as 1. So next we need beta 3, which will be equal to d3 minus a3 beta 2 divided by alpha 3. So we have simply said i3. So there is no, so fully there is no any confusion. Next will be finding d3. Where is d3? D3 is over here 0.5 minus a3 is over here 2. So as you can see here 2 into beta 2. Beta 2 we just calculate it as 1 divided by alpha 3. Alpha 3 is 3. So we get this value as minus 0.5. Next we'll be computing the value of beta 4, which will be equal to d4 minus a4 beta 3 divided by alpha 4. So this will be equal to d4 is here over here minus 1.75 minus a4 is over here 1.5 into beta 3 is over here, we just calculate it, which is equal to minus 0.5 divided by alpha 4 is 1. So on solving this, we will get this as minus 1. Now we have completed our first step and second step. So as I mentioned before, now for our final step, we'll be setting xn equals to beta n and we'll be computing xi using this formula. So let me simply write over here for our final step. So what we'll be going to do is we need to setting x4. So we need to set xn equals to beta n, and we have our value of n as 4. So let me simply set x4 equals to beta 4, which means our value of x4 will be simply equal to minus 1, and we need to compute x3, x2 and x1. So our x3 will be equal to, so in the before what we did was we ran our I from 1 2 3 4. So our we ran it in this way, but now we'll be running our I from 4 3 2 and 1. So we'll firstly computing value of x3. So my formula for xi is beta I minus this. We'll be simply writing this down. So xi equals to beta I minus ci xi plus 1 divided by alpha I. So simply we'll be computing this. Now I already have my value of x4. Now x3 will be equal to beta 3 minus c3 x4 divided by alpha 3. So let me simply write this down. We have beta 3 as minus 0.5 minus c3. Our value of c3 will be over here 1.5 into x4 is minus 1 divided by alpha 3. Our value of alpha 3 will be over here 3. So on solving this, we'll get this value as 0, is equal to 0. Now we need x2. Our x2 will be beta 2 minus c2 x3 divided by alpha 2. This will be equal to beta 2 will be 1 minus c2. We'll have our value of c2 from here 2 into x3 is 0. So basically this is going to be 0. We can simply write this as 1. So our alpha 2 is equal to 2. So it's basically, so this is basically as 1. Now for our final, we need x1. So x1 will be equal to beta 1 minus c1 divided by x2 divided by alpha 1. So now I have my value of beta 1 over here, which is equal to 2 minus c1. C1 is right over here, which is equal to 8. So let me simply write that 8 into x2. I have my value of c1 as c1 as 8. Now for my value of x2, I have my x2 calculated over here, which is equal to 1 divided by alpha 1 is equal to over here, which is equal to 4. So let me simply put that down. So I get this as 2 minus 2 will be equal to 0. So now I have my value. So let me write it over here. So I get x1 comma x2 comma x3 comma x4 equals to x1 is equal to 0, x2 is equal to 1, and x3 equals to 0, and x4 equals to minus 1. So in this way we have solved this equation. So just for our checking, this will be equal to x y z w equals to 0 1 0 minus 1. So as you can see here in our first equation we have 4x plus 8y equals to 8. So if I put x value 0 and 8y value 1, we get 8 into 1 equals to 8. Similarly we can check on all these equations as well. So in this way using Thomas algorithm we'll be solving our equation and we'll get our required value. Hope this video was helpful to you, and if you have any queries you can comment down below, and if you liked our content and what we are doing, do subscribe the channel. Thank you.